All right. So we will begin today's session. So in today's session, primarily I would like to revise weeks 1 and 2, along with a little bit discussion on mock. And if time permits, I would like to take any final questions you have before your end, before your quiz. Is that okay?
Yes, sir.
Yes, sir.
Great. So yeah. All right. So one more minute. Let me share my screen. All right. I hope my screen is visible to all of you. So this is revision session 2. So revision session 1 has already happened on Wednesday. Okay. So in that particular revision session, we have covered or revised week 3 and 4. Those who have joined the session would know that, but those who have missed that particular session, if you need some clarifications or what kind of questions you can expect from week 3 and 4, then you should definitely go back and watch that particular session. And in today's session, I will start off with weeks 1 and 2 revision. Okay. So we'll not spend too much time on anything. So it's kind of a revision session. So we are not going to sit and prove things or maybe sit and have a great long discussions. Okay. So if you need any further clarifications on any of the topics, then you should definitely go back to the earlier live sessions of that particular week. And yeah, so only there you can clear all your doubts completely. So in today's session, I expect you know the 80% of the things, and the rest 20% we will just clear them by solving problems.
Excuse me,
Okay.
sir.
Yes.
Sir, please pin the YouTube link in comment section.
All right.
Yes.
Yes, it is built. Okay. And again, a fair warning to all of you. So today's session would be not slightly, morely inclined towards our quiz preparation. Okay. So if at all I'm skipping a topic or I'm not doing problems related to those topics which you expect, and then that implies that it is not that important to qualifier. It is not that it is not important concept in mathematics. Okay. So I hope you guys understand that. So do not question me or ask me that you missed that or you missed this. Can you explain that? Can you explain this? I will explain that at the end of the session, but not right away. Okay. So let's start. And let me start with the quiz one blueprint. This is quite important for the qualifier students because this is the first exam you are going to give in this particular journey, right? At least for math one, the syllabus for quiz one will be weeks 1 to 4. Okay. So do not go and sit on preparing the concepts from week 5 or week 6 has been released today. So it doesn't mean that we have released the contents, we will ask questions from that. Okay. I hope most of you know this. So weeks 1 to 4 will be the syllabus and the total marks will be 40 marks. Okay. But this will be scaled to 100 later. But as of now, the question paper is for 40 marks. And the total time you get is ideally it's 60 minutes. But you should be smart here. Like if you want more time for math, you should finish the other topics like English as quick as possible and take some time from English and keep it for math. But the paper can be solvable within 60 minutes. Okay. And coming to the weightages, so we have more weightages for week 2 and 3 because there the concepts are very heavy. Even week 4 has heavy concepts, but week 4 is pretty new compared to weeks 1 to 3. So therefore, this is how the weightages for each week are. Okay. And coming to the question types, there will be two types of questions. One is pretty straightforward questions like a straightforward MCQ or MSQ or NAT. Each question carries 4 marks. Okay, so it will not be connected to previous question or the next questions. It will be a single straight question. And the other type would be comprehensive type question. So you will be given some context or comprehension. And below that, there will be some 1 or 2 questions, or maybe 2 or 3 questions followed by it. Okay. And each comprehension question carries 5 marks. That means if the comprehension has 2 or 3 subparts in it, all 3 subparts collectively will carry 5 marks, not individual question carries 5. Okay. And also at this point, I would like to mention about the difficultiness of the question paper. So out of the questions, out of these 9 questions, if I don't include the subparts, 50% of the paper is treated to be easy. Easy, I know this is subjective. Like it may be easy for me, not for you. But here, easy means the question is kind of similar to one of your activity questions or practice assignment or graded assignment question. Also, there will not be any trickiness in the question. If you had solved any activity question earlier of that kind, or practice assignment or graded assignment that kind, this question can be solvable, and it can be solvable within 3 to 5 minutes. Okay, so 50% of the paper will be like that. And the next 35% will be of medium level. Again, when I say medium level, it means these particular questions also you would have seen a small flavor of these questions you would have seen already in activity questions or graded assignment questions or practice assignment questions. But these questions take little bit of time to compute, like it takes some time to calculate, or it's kind of slightly lengthier. So concept is known to you and the question type is also known to you, but it takes some time to get to the solution. Like let's say 5 to 7 minutes. And the last 15%, I wouldn't say it is hard, rather I would call it as tricky. Why I'm calling this as tricky? Because you wouldn't have seen this kind of question in any of the graded assignments or activity questions or practice assignments. So this looks like a new question, but from the same concepts. So we can't go beyond the 4 weeks concepts, but within these 4 weeks, the concepts, if you are good at all the concepts, then these questions will also be considered as easier for you. Okay, but your primary focus in your exam should be identifying these 50% questions which are easy and try to solve them first. And that will make you to get 20 marks out of 40, which means more than 40 when it is scaled to 100. Okay, so you will definitely qualify. And this 50 marks, 50% of the marks can be achieved by solving mock, okay, and following through the revision sessions, both the revision sessions. If you just simply blindly follow these 2 revision sessions, as well as if you had solved the mock paper completely. Solving mock paper doesn't mean by harding the answers. Okay, solving mock paper means you should know the concept, you should know the question, and if I had waked you up at some, let's say 1 a.m. in the morning, you should be able to solve it. Okay, solve it from step 1 to step last. Okay, so yeah, that's about the weightages and a small blueprint about the exam. Okay, let's now focus on today's agenda. So today's agenda is to revise week 1 and 2, and these are the important concepts that I'm going to revise today. That means these are the important concepts for your qualifier or the quiz 1 exam. Okay, so we will be starting with straight lines and quadratic functions that will cover week 1, and then we will move to system of linear equations, and we will see how to write the given system in matrix vector form. Okay, and the next thing we will spend some time on is commenting on the existence of the solution. Like given a system, you should be able to say whether that system has a unique solution or no solution or infinitely many solutions. And of course, the final part is you should know how to solve a given system of linear equations. Okay, so straight lines, or sometimes it is named as linear functions, or affine functions. So there is a slight difference between this linear functions and affine functions, which is not required for us as of now. But you just be careful that when we say linear function, it represents a straight line. Okay, and when we say affine, that function is also the graph of that particular affine function is a straight line. Okay, so you'll see one by one. We will start with straight lines. Okay, so basically the definition of a straight line is it is just a one-dimensional figure that basically extends infinitely in both the directions. So most of you know what a straight line is and how it looks like. On xy plane, this red colored line is a straight line, right? And this straight line can be expressed in many ways. In mathematics, there are several ways to represent this. And the most common representation is y is equals to mx plus c, which is called slope intercept form. Why it is called slope intercept form is because this m actually represents the slope and this c here is the y intercept. Okay, so on the graph, you see the point where the line and the y-axis intersects is called the y-intercept, which is 0, c. Okay, and the slope we will discuss about slope, but the slope is basically rise by run, like how inclined is your line. So is it like this or is it like this? So how inclined is it? Is it flat like a horizontal line, or is it steeper towards vertical line? So that is captured by the slope, and we will see what exactly that slope is in the below slides. Okay, now this straight line expression is basically an equation, and this is actually a relationship between the variable x and the variable y, right? So how y is related to x is what this equation captures. So the main point of studying straight lines in our course is to identify these kind of relationships. And this is very important skill that we have to develop. So some variables may be dependent on each other and some variables may not be dependent on each other. But the variables which are dependent on each other, they will have a relationship among themselves. And some relationships can be represented using straight lines. For example, distance can be a variable and time can be another variable, and this distance and time are related with speed, and we know that distance is equals to speed cross time, and this is like if you treat this as some variable, distance as a variable and time as a variable, you represent d with some y and time with some x, and it looks like y is equals to something multiplied by something multiplied to x, which will if you draw the curve which actually represents a straight line. So that is why studying straight lines is important in our course at least. Okay, so it forms a relationship between two variables. And let's see an example. This is the mock question 1 in the mock. So this question states a missing woman's height is estimated using a human femur bone found during the police investigation. Okay, the formula used to estimate the height is h is equals to 1.8 f plus 70, where h is the height in centimeters and f is the length of the femur bone in centimeters. Okay, so basically what this equation is actually representing, this is a straight line of course, but this is an equation which represents the relationship between the height and the length of the femur bone, right? So this is the relationship. Now what is the question is, the missing woman's femur bone length is found to be 35 centimeters. Okay, so this is, so in a given information or the data, you should identify what all things that are necessary to you. Necessary means that those numbers are important, you can't change that. So the other statements, you can replace it with the missing woman's height, you can replace it with some other thing, right? Like missing man's height or something else. It doesn't matter. That is just the context. But the math inside the context is very, very important and you should identify those things first. So this equation is important that you have to highlight, and that equation is basically the relationship between height and the femur, length of the femur bone. And the length of the femur bone found is 35 centimeters. So this is an important information for us. Suppose the maximum height of a female in this locality is 195 centimeters. So this is also important. And the minimum length of the female femur bone is 15 centimeters. So what does this information tell us is basically the later statements tells us is h is less than or equals to 195, right? Because it is said that the maximum height of the female in this locality is 195 and h represents the height. So from this particular statement, it is evident that h cannot be greater than or equals to or greater than 195. The next statement is this f. This is the minimum length of the female femur bone is 15 centimeters. So that means this f is greater than or equals to 15. So converting the English statements to the mathematical expressions is also a serious skill that you have to develop. Okay, so these two statements basically says these two things. Now, four options are given to us and we have to decide what options are correct. Okay, so sometimes this may be incorrect also. You should be a little bit careful. Okay, so once you read the question, you should know how to solve this particular question. So basically, this is a relationship, right, between h and f. In order to find h, you need f, right? So to find h, option A says to find h, the estimated height of the missing woman from the formula, we have to substitute f is equals to 35 in the formula. And option B says to find h, the estimated height of the missing woman from the formula, we have to substitute f is equals to 50 in the formula. So you guys tell me, out of option A and B, which one is the correct one? So in order to find the missing woman's height, what should I substitute in place of f?
35 centimeters.
Sir, A
35,
option.
sir.
A option.
A option, right? Because 35 centimeters is the length of the femur bone of the missing woman, whereas 15 is the minimum length of the female femur bone. So out of the within the information itself, we can identify option A is correct and option B is incorrect. Okay, So if we move on, then the next option is the minimum height of a female in that particular locality is 97 centimeters. So how can we get this? How can I find
By putting
minimum
f
height?
equal to 15
Correct.
in the
So
equation.
H min, let's say this is height of the minimum height of a female. So H min is 1.8 times this F. I have to substitute F here plus 70. So which value of F should I substitute? 35, 15. So from this information, so minimum height actually corresponds to the minimum length of the female femur bone, because this is a straight line, and you see that as the F increases, as this value increases, the total height will also increase. So that means minimum height, in order to capture the minimum height, you should substitute the minimum length of the female femur bone. So that means I have to substitute 15. So if I calculate, what will I get?
97.
Okay. So we will get 97, which implies that option C is correct. The maximum length of the female femur bone in that particular locality is 32 centimeters. Now, in order to find the maximum length of the female femur bone, so now I have to find F max. This is 1.8 and this is 70. Now, what should I substitute in place of H?
H
195.
max.
H max, which is 195. So the
95.
maximum value of H, possible maximum value of H, which is 195. So from here, I can actually find F max. If I find F max, what will I get? This is 195 minus 70 divided by 1.8. Right? So I think you can solve this. Solve this and you will see that option D is incorrect, correct?
Incorrect,
Solve
sir.
this.
Incorrect.
Incorrect. Okay. So this is how we solve this particular problem. Okay. And this is related to the concept of straight lines. All right. Now let's move and let's have a small discussion on what exactly slope is. Okay. So slope, basically denoted as M, okay, measures the direction and the steepness of a line. So basically, as I mentioned above, it measures the direction and the steepness. So in which direction is my line and how much steeper is that particular line. So this theta here captures the steepness. So is it like this? Is it inclined at angle of theta, or is it more than theta, or is it less than theta? And is it in this direction, or is it the opposite direction like this? Okay, so these things is captured by the slope, and it is basically the ratio of the change in the vertical direction, which is called as rise, to the change in the horizontal direction. Okay, so the change is basically, if I move along x-axis, so I will move from this point to this point. Within this movement, how much did I change with respect to the y-axis? So at this point, at this particular point, this is where y is. But as I move to this point, my y value has moved to this. So from this point to this point, my y has changed. And how can I capture that? This is basically the difference between this point and this point, this height to this height, which is y2 minus y1. Right? And the change in x is from this point to this point, which is x1 to x2. Right? And slope is basically the ratio of these two. So slope is the ratio of these two, which is y2 minus y1 divided by x2 minus x1. And slope, and this is just the connection between 2 points on the line and the slope. And this is how it is connected. If you know the 2 points on a straight line, then you can compute the slope using this particular formula. So you just have to do the difference between the y coordinates divided by the difference between the x coordinates. And this is the slope. And sometimes if you know, if theta is given to you, this is actually equals to the tan theta. Those who know trigonometry, you can see it from this triangle. Tan theta is basically opposite side by adjacent side. Opposite side length is y2 minus y1. Adjacent side length is x2 minus x1. All right. So there are a couple of observations about the slope. Okay. So if m is positive, okay, then the straight line will be like this, or it is said as increasing. Okay. So increasing function. Why it is increasing function? So when you increase the value of x, your y value will also increase on the line. So if you see here x1, y1, x2, y2, you know that x1 is less than x2, as well as your y1 will be less than y2. So your x values, if you keep on increasing your x values, your y values will also increase if m is greater than 0. Whereas if your m is less than 0, then it will be decreasing. It will represent a decreasing function, and your straight line will look like this. Okay, so if it is looking like this, then you see 2 points on it. This x1 is less than this x2, but this y1 will be greater than this y2. You see from heights. Okay, so from there you can easily see that if m is less than 0, your straight line will look like this. So I will draw here. If m is less than 0, your straight line will look like this. If m is greater than 0, your straight line will look like this. And there is one more thing. If m is 0, then how will your straight line look?
It will be vertical.
Vertical. Okay, so will it be like this, or will it be like this? So line L, line M, line P. So which line will have slope 0?
Horizontal line.
So line P, right?
Yes. Yes.
Yeah. So if slope is 0, that means the line is parallel to x-axis. Straight line is parallel to x-axis. What happens when your straight line is parallel to y-axis? What is the value of m?
Infinite.
Okay, that's a good answer, but that is not the correct answer. So basically, m is not defined. Okay. So you cannot call it as infinite, but rather you should say for parallel lines which are or vertical lines which are parallel to y-axis doesn't have any slope. So slope for those lines are undefined, not defined basically. Because from the definition you can see, so these lines, there is no change in x at all. So the x value is constant, but the y values can change from infinity to minus infinity, top to bottom. So you cannot actually capture the ratio properly, right? So once the ratio is not defined properly, so or your denominator becomes 0, and when it is 0, it is not infinite basically. It will be undefined. You don't know how much rise happened with respect to the how much change in the horizontal direction, because there is no change in the horizontal direction. So these are small things that you have to observe. Okay, and this is about the slope. And moving on. So in order to find the equation of a line passing through 2 points, x1, y1 and x2, y2. Again, you can use some standard methods or general formula and you can reduce this. Actually, we are just using the slopes. So you take 3 points. With one point is x1, y1, another point is x2, y2, and the third point will be x3, y3. Sorry, xy. Okay, and the slope of the line that passes through these 2 points is y2 minus y1 by x2 minus x1, and the slope that passes through these 2 points will be y1 minus or y minus y1 divided by x minus x1. So if you equate those two, those slopes must be equal because they are on the same line. If you equate those two, you will finally get this particular equation. And yeah, given 2 points, you can, using this formula, you can directly get the equation of a straight line. And if you carefully observe, this is basically the slope. And given a slope and a point, right, you can simply write y is equals to m times x minus x1 plus y1, where x1, y1 is the point and m is the slope. All right. Any doubts so far?
No, sir.
No, right? Okay. So moving on, the other important thing is you should know how to find the point of intersection of two straight lines. Okay. So let's say you have two straight lines, which is y is equals to m1x plus c1. Okay. And another straight line equation is y is equals to m2x plus c2. Now this point of intersection between these two straight lines is basically this point. And this point, the logic to find this is basically this point actually satisfies both the equations, right? So x naught, y naught should, when I substitute that in this equation, it should get satisfied. When I substitute x naught, y naught in this equation, it should get satisfied. So if I substitute them, I have two equations, and both the equations, if you see the left hand side, this one, if you see the left hand side, both are y naughts. Therefore, the right hand sides should also be equal. So if I equate those two, we will get this equation. And from here, I can actually find x naught, right? I can bring all x naught terms on one side and constant terms on the other side. Then take x naught common from the left hand side, and you will finally observe that x naught will be c2 minus c1 by m1 minus m2. And take this now, take this thing and substitute in one of the equations. So you take this and substitute it here. You will have m1 times this thing plus c1. If you simplify this, you will get y naught also. And this is between two straight lines. And sometimes you may be given like this also. So a quadratic function and a line intersecting. Then what will you do? So a quadratic with a line. And there is an intersection point between a quadratic and a line. The logic always stays the same. Okay, so the intersection point should satisfy both the given functions. Okay, so that's the logic you should use. So you should substitute that point in the given straight line equation. You should substitute that point in the given quadratic function. And then you will have two equations with you with two variables. Then you have to solve. You can solve it and get the intersection point. Okay. So this is also quite important. I'm not doing any examples because I will do the examples whenever it is much necessary. Okay. So now let's move. Let's move to the second topic, which is quadratic functions. And quadratic functions, its general form will be f of x is equals to ax square plus bx plus c, where this is a quite important thing. You should not forget this, where a not equals to 0. Okay, so this is the general form, because when a becomes 0, this term will no longer be there in your equation, and the resultant will be a affine function. Okay, so that is why a should not be equals to 0, and again quadratic function will have three terms. This is called quadratic term, which has x square in it and a coefficient, and this is called the linear term, and this is called the constant term. Okay, so there will be three terms in the quadratic function, and there will always be quadratic term. The other two terms can go to sometimes may be missing, because when b becomes 0, the middle term will miss. When c becomes 0, the last term may miss. But the quadratic term should exist in order to call that particular equation as a quadratic equation. Okay, and the graph of the quadratic functions will be of two kinds. One can be an upward parabola, which is on the left side of your screen, and the other can be a downward parabola. When will this be upward or downward is you can judge just by looking at the sign or the value of a. If a is greater than 0, then it will be an upward parabola. So a greater than 0, upward parabola. And when a less than 0, you will have downward parabola. Okay, and these are the only two possible graphs for quadratic function. So you cannot have any other fancy kind of graphs like this or like this. Okay, not even a straight line. Okay, either upward or downward. All right, and there are many terminologies you should know, and sometimes in questions the information given to you will be using these kind of terminologies, and you should know what these terms mean basically. So when you have a quadratic function, f of x is equals to ax square plus bx plus c, where a not equals to 0, and when you plot the graph, okay, and after plotting the graph, there are certain special points that attract our eye, right? So this is one such point, this is another point, and this is the just bottommost point. Okay, and when I draw a vertical line parallel to y-axis which passes through this bottom point, that line also has a special name, which is called axis of symmetry. And since it is a line, the equation of that line is basically x is equals to minus b by 2a for a quadratic equation of this kind, quadratic function of this kind. Okay, and it doesn't matter whether it is a downward parabola or upward parabola, the axis of symmetry will always lie at this particular point. Okay, so x is equals to minus b by 2a is the axis of symmetry. So in some questions, if we say the axis of symmetry is x is equals to 2, what does that mean? X is equals, that means minus b by 2a is actually 2. So this is the information you should infer from the statement given there. Okay. All right. So this is the axis of symmetry, and that axis of symmetry is this line. Which line? This line which passes through the bottommost point when it is upward. When it is downward, it will be the topmost point. Okay. And that is x is equals to minus b by 2a. And the bottommost point has a special name called vertex. Okay. So vertex of the parabola. And this vertex will lie, or vertex point is actually minus b by 2a will be the x coordinate, because x coordinate of this point and this line, on that particular line x coordinate will be just minus b by 2a. So it will be minus b by 2a, and this c minus b square by 4a is the y coordinate, and you can get this just by substituting minus b by 2a in this equation, because this particular point should satisfy this equation, this function, right? Therefore, if you substitute minus b by 2a here, you will get the y coordinate of your vertex. Or if you remember the formula, then that will be c minus b square by 4a. And the other two special points which lie on the x-axis, right? Those 2 points are basically the curve intersecting x-axis, right? At these 2 points, the function value is 0. So this will be 0. So y coordinate will be 0. Okay, so zeros of a quadratic function occurs at f of x is equals to 0. Okay, so those x which satisfy this f of x is equals to 0 will be these two points. And that those 2 points are, one is at x is equals to minus b plus root over b square minus 4ac by 2a. And the other point
So
will be,
there would be fy0 now. So there would be fy0 now.
fy0.
Yes, sir.
Why fy0?
Because, sir, at every root there should be some x, not y0. Matlab, y should be 0, na, sir? Because the root will lie
Yeah,
on the
y
x
is here f of x, right? So y or f of x both are same, na?
Okay, sir, got it.
F of x is y, right?
Okay.
So this is y. Okay, so f of x should be 0 or y is 0. So that should happen. That's it. Okay. All
Okay.
right, no confusions. Great.
No.
So these are zeros. And the last special point is where our curve intersects y-axis. So x-axis, when the curve intersects x-axis, those points are called zeros of the quadratic function. And the curve that intersects y-axis, which is called y-intercept. And you can see for y-intercept, your x is 0. So x is 0 on y-axis. So if you simply substitute x is equals to 0, you will get the y-intercept as 0, comma c. All right. So these are some main terminologies that are associated to the parabola, okay, which is the graph of a quadratic function. All right. So the next important thing for your exam is the roots of a quadratic equation. So firstly, we should understand what a quadratic equation is, and then we can solve the quadratic equation to get the roots of the quadratic equation. So basically, the zeros which we have seen for the quadratic functions are basically the roots of the quadratic equation. So what I mean is, so roots of f or roots of quadratic function or zeros of the quadratic function is basically the values of x such that f of x is 0. Okay. So all the values of x, whenever I take some value for x, if I take the function of that value, if it is giving me 0, then that particular value of x is called as a zeros to a quadratic function or roots of a quadratic function. Okay. So for that, what we have to do, we have to make f of x is equals to 0 and find x. So if I make f of x is equals to 0 and I know f of x is ax square plus bx plus c, and if I substitute that here, we will get an equation. Ax square plus bx plus c is equals to 0. So now this is called a quadratic equation, and the roots of this quadratic equation occurs at, so there will be two roots which are minus b plus or minus root over b square minus 4ac by 2a, and this is the very famous quadratic formula, right? Now, so this is about the roots. Now we can also talk about, not every quadratic equation will have two roots. So if a quadratic equation has two roots, two real roots, then you see this particular b square minus 4ac which is under the root. This should be greater than 0. And this is also called discrimination. Discriminant. Okay. So if your quadratic equation has two real roots, then this should be positive. If this is positive, then this plus or minus makes sense. So sometimes, so some quantity will be added and some quantity will be subtracted. You will get two real roots. You can also have one real root repeated twice. So one real root. Okay. When can you have one real root? When your b square minus 4ac is exactly equals to 0. So when this is equals to 0, then this term, there will not be any term like this, right? This becomes 0. Then the only root possible is minus b by 2a, right? And the only root will be at minus b by 2a. And again, this is again the axis of symmetry. So the vertex point will lie on the x-axis. Okay, so these things you should infer straight away. So when you see the same equations coming up, you should have you have to infer something from that. Okay, and the last thing, we can have no solution also or no real roots. When can we have this case? When you have b square minus 4ac, when this is less than 0, then you observe that square root of a negative term is not a real number, right? So when that is not a real number, the whole thing will not be a real number. And it implies for us that there will not be any real roots. There will be imaginary roots, but we don't care about imaginary as of now. So what we care really is the real, whether it is real or not. That's it. So these things can be easily seen from the graphs. So when your graph, so there can be 6 kinds of graphs possible for any quadratic function. So the first graph, so the graph will look like this if your value of a is greater than 0, as well as if your discriminant b square minus 4ac greater than 0, because you have two real roots here, right? Your graph is intersecting x-axis at two different places, so that means two zeros. That means for your quadratic equation you will get two roots. So that means b square minus 4ac is greater than 0. So b square minus 4ac greater than 0 and a greater than 0, this kind of behavior it will be. And also specifically, if you see, one is negative root and another one is positive root. So I didn't mention, your graph can also be like this, both positive, both negative, one negative, one positive. So all these are possible cases. Okay. And the next case is, if your a is greater than 0, then it will be an upward parabola. Not only that, your curve, your parabola is touching x-axis only at a single point. And that point is also the vertex point, right? So this point is also a vertex point. So that means b square minus 4ac is equals to 0. The last, in the top row, the last case is a is greater than 0 again, because it is an upward parabola, and b square minus 4ac is less than 0. So given any quadratic function to you, like let's say 4x square plus 3x plus 5, something like this. And if you have to roughly plot that particular function, right? So what will you do? You see the sign of a first. If it is positive, you think that these three possible cases, the above row possible cases. Then you find the roots of the quadratic equation. Then from the roots, you can roughly guess the solution, roughly guess the graph. Okay. So similarly, I think you can, from here, you can do the bottom three. Can you all tell me what will happen? When will I see this particular graph?
A is negative in all of them.
Okay, A because it is a downward parabola, so A should be less than 0. All right. When will,
Discriminant greater than 0.
correct. So it has two real roots. So discriminant is greater than 0. Here again,
Equal to 0.
one real root, so equals to 0.
Here
B
negative.
square minus 4ac is less than 0. Okay. So now you can actually draw roughly, given any quadratic function to you, you can roughly draw how the graph looks. Right, from these
So
cases. You just have to be careful about the sign of A and the discriminant value. Okay.
and discriminant is based on the vertex only. Right, sir?
Yeah. Correct. Okay. So let's solve one more problem. Okay. Before this. Okay. So let's solve. Nothing else. Did everybody got what we discussed so far? Any
Yes,
doubts?
sir.
Yes.
Okay.
Yes, sir.
All right. So let's solve this particular mock question. And let's get some hands on quadratic functions and quadratic equation. Okay. So a footpath of width x meters is constructed around a rectangular garden of length 7 meters and breadth 5 meters. The total area of the garden, including the footpath, is 99 meters square. Okay. So breadth is 5 meters, length is 7 meters. The total area of the garden, including the footpath, is 99 meters square. Which of the following statements is are correct? Okay. And the statements are all are related to find the value of x. Which equation should I solve? Right. Before for that we need to form the equation, and we will see what kind of equation is formed from the given data. All right. So it is given that this whole area is 99. Right. This is 99 meters square. And we also know this green gardens area. How we know? Because the length and breadth is given to us. So from the length and breadth, and it looks like a rectangle, right? It is also given that it is rectangle. So from there we can get actually get area of this rectangular garden, right? So what will that be?
35.
35 length into breadth. So 35 meters square. All right. So now this is 35, overall 99. And now we know the footpath area also, right? How can we get the footpath area?
By making an equation in x.
Right. Okay. This is basically 99 minus 35. That is okay. But before that, we need to form some equations, right? So from where we get the equations? Basically, when we try to find the length of the bigger rectangle and the high breadth of or the height of the bigger rectangle. Okay, so when we find these two in terms of x, and we know that length into breadth is equals to total area. Right? So total area, we know that it is 99. So right hand side is clear to us. The left hand side is basically finding the length and the breadth. So what will be the length and breadth?
Length will be x plus 7 and breadth will be x plus 5.
2x plus 7 and 2x plus 5.
Correct. So that is why I have erased this. So in order to find this length, we need this whole length, right? So that means we need this, and we need this. So this part is very clear because it is just the 7 meters. And this part is x, and this part will also be x because it is said that a footpath of width x meters is constructed around. So width is always the same for the footpath in 4 directions. So the total length will be 7 plus 2x. Okay. Similarly, if I have to find the breadth, I have to find this length, this whole length. So this length, you can again divide it into 3 parts. Middle part will be 5 meters, and the top part is x, and the bottom part will again be x. So therefore the total breadth is 5 plus 2x. So once we got this length and breadth in terms of x, we just have to substitute in the equation. So if I substitute it, I will get 7 plus 2x into 5 plus 2x is equals to 99. So if I expand this, I will get 4x square. So I am writing x square terms first. And then if I write the x terms, so 2x multiplied by 5 will be 10x. 7 multiplied by 2x will be 14x. Plus 35 is equals to 99. So from here 4x square plus 24x plus 35 is equals to 99 is the equation that we have formed from the given information. Right? We just use the formula that length into breadth is equals to total area, and we have used it on the outer rectangle. Right? So therefore you can see from options that 4x square plus 24x plus 35 is equals to 0 is not the correct quadratic equation. X square plus 12x plus 35 is also not the correct quadratic equation. So 4x square plus 24x plus 35 is equals to 99 to get the values of x. So this will be the correct equation. Okay.
Yes, sir,
And
clear.
yeah. So the next thing is, once we get the quadratic equation, the next thing is to find the value of x. Right. So to find the value of x, we form the complete quadratic equation. 4x square 24x minus 35 minus 99, which will be 64 is equals to 0. Now you can cancel out or you can take 4 common, and you can write x square plus 6x minus 16 is equals to 0. Right. So from here x square, so it's like you can directly use the formula, but you can also do this method. Okay. So you will get, if you take x
plus
common,
8,
x plus 8
x minus
x
2.
minus 2 is equals to 0. And from here you see that x takes value minus 8 and x takes value 2. Out of these two values, can x take minus 8? What is x
No.
actually representing? X is representing the length or the width. So we cannot have negative width, right? Like it doesn't make sense when I say minus 5 meters, right? So that is why x, even though x mathematically can take two values, but as this is connected to the context, contextually x is equals to minus 8 doesn't make any sense. So therefore we neglect x is equals to minus 8, and the only value that is possible for x is 2. Okay, so we have that. Now, once you know x is 2, there can be many questions like this. If the footpath is covered with square tiles and the length of the side of each tile is 0.2 meters now. So this is like you have a square tiles, each length is 0.2, each side length is 0.2, 0.2. Okay. Now find the number of tiles used to cover the footpath. So we know the area of this square tile, right? So the area of this each square tile is 0.2 into 0.2, which is 0.04, right? And now for one tile can cover 0.04 meter square, and you have to cover the whole footpath, right? So that means one tile is covering 0.04 meters, and it is said that you have to cover the whole footpath. Whole footpath area is, so this is 35, this is 35, and the whole is 99. So 99 minus 35 will be the area of the footpath. Correct. So this area is basically 99 minus 35, which is 64. So 64 meter square is the total footpath area, right? And one tile requires 0.04 meter square. How many tiles do you need to cover whole 64 meter square? So for this, you can just use your traditional methods, right? We do this cross multiplications, right? And we find question mark into 0.04 is basically 1 into 64. And this question mark is 64 by 0.04, and it is 1600 tiles. All right, so this is how you solve questions related to quadratic functions and straight lines. Okay, any doubt? Because I think we are moving to week 2. So any doubt here? So solve problems related to this kind. Okay. So just revise all the things that I have discussed in week 1. Okay.
Yes, sir.
All right. So let's move to week 2. As I said, week 2, we are going to focus on 3 main things. One is you should know how to write a given system of linear equations in matrix vector form, because that's the starting point to week 2. So if you don't know how to represent them in the matrix vector form, then given 5 equations to you, it will be very, very difficult for you to solve. Okay. So let's say this is the system of linear equations given to you. Oh shit, I have forgot this. Okay. So this is the system of linear equations. Let's say this is the system of linear equations with how many equations and how many variables?
So
M
n variables.
equations.
Okay, so nm. So one is variables and one is equations.
N variables, M equations.
Correct. So n variables, and those n variables are x1, x2, xn. So these are the n variables. And m equations. So you can see, right? This is the first equation, this is the second equation, and so on. This is the mth equation. Okay, you can count this b's also, b1, b2, b3, b4, and so on, bm. How many b's are there? So there are m b's, so m equations. So this is a system of n variables and m equations. And how do I represent this system of linear equations in matrix vector form? I just pull out the coefficients of each variable in each equation and put them as a row. So from the first equation, I will pull out all the coefficients and put them in the first row. So likewise, the second equation coefficients will go sit in the second row. And so on, so forth. The mth row will contain all the coefficients that are in the mth equation. Okay. So this is how we represent the matrix vector form of the given system of linear equations. So let's solve an example. Okay, so this is again mock question. So given a system of linear equations like this, so this is a system of two variables and two equations, right? So if I write the matrix vector form, how will this look?
In first row, there will be 3, 4,
3, 4, 2, minus
2
1,
minus
minus
1,
1
and you just write 18 and 1.
minus.
Okay, never get confused with writing all x variable coefficients on one row and y variable coefficients on the other row. Okay, so this is wrong. All right. So this is the correct matrix representation. So once you have the correct matrix representation, then we are ready to solve the system of linear equations. Okay, we will come back to this example again after we briefly revise the method. Okay. So how to solve a system of linear equations? Okay, so the method is basically elimination and back substituting. Okay, so once you convert your system of linear equations into the matrix vector form, so this is the matrix vector form. Right? Now what you have to do is basically we have to use row operations. Right? Row operations are like you can either subtract one row from another row, or you can simply scale a particular row. Like you can multiply a real number to a particular row. That's it. So these are the only two operations allowed when I mean by row operations. And our target is basically to make the bottom rows zeros. Okay, so we start making this 0 and this 0 and zeros. So we kind of make zeros from the bottom. Like we will try to bring zeros at the bottom like this. And there will be at some point, we will no longer be able to make zeros. So we will be left with some R rows, which are non-zeros. But even there also, what we have to try is, we have to try something like this. So the lower diagonal part. So treat this as a diagonal, treat this as a diagonal. So the lower part of the diagonal entries, we will try to make them 0. And we can make them 0. So it is possible. So we will make this as zeros. So some rows will become zeros directly by using the row operations. And after a certain point, complete row will not be 0, but we will slowly make zeros below the diagonal. And above the diagonal, they can be some non-zero entries. And on the other side, like the constant side, when we are doing the row operations, they will no longer be b1, b2, b3, and so on. So when they will, so some operations will be performed on it, and it will become b1 tilde. So some other value other than b1, there will be some other value b1 tilde, b2 tilde, likewise. So there will be br tilde because the rth row contains br, and br will change to br tilde. And after that, r plus 1 will be br plus 1 tilde. And so on, the last row will have bm tilde. Okay, so these are different from b1, b2, b3, bm we have. So once we reach this kind of matrix, Okay. Now we are ready to comment on the solution as well as compute the solution. So both can be done at the same time, like one after the other at least. So how can we conclude or comment on the existence of the solution just by looking at this matrix is, so when you make this all zeros, okay, and if this is all zeros and you have some non-zero entries here, okay, so these rows after rth row, if r plus 1, r plus 2, r plus 3 and so on, mth row, everything is 0 and you have some non-zero entry on the right side. Okay, so then no matter what your x1, x2, x3 and so on, xn are, you cannot satisfy that particular row or that particular equation because the left hand side will be zeros, the right hand side will be non-zero. A 0 can never be equals to a non-zero element, right? So that's the condition for no solution. So if you see any of b r plus 1, b tilde r plus 2 to b tilde m are non-zero, okay, so then there will not exist any solution. Okay, when will we have a unique solution? So when your r, so this r, the number of rows which are non-zero, if that rows is equals to the number of columns you have. Okay, so this we have n columns, right? Excluding this column, you exclude this column for the time being. So you have n columns, each column represents each variable. So if your r, the number of non-zero rows are equal to the number of columns or the number of variables, if I have to be more precise. So you have n variables here. So if your non-zero rows are equal to the number of variables, then you will have a unique solution along with this b tilde r plus 1, b tilde r plus 2 and so on, this b tilde should be 0. So all these things should be 0 firstly. In order to have solution, these things should be 0. If any one of them is non-zero, there will not be any solution. If these things are 0, then there will be unique solution or infinitely many solution. Okay, so these things are 0 and if r is n, then you will have unique solution. And if your r is less than n and this condition is again and this is satisfying, okay, then you will have infinitely many solutions. So lesser equations with more variables, you will have chances of getting infinitely many solutions. Okay. All right. Any doubts here?
So could you please repeat the last part? No solutions, unique solutions, and infinitely many solutions. The
So,
condition.
okay. So the conditions are for no solution, this all 0 rows have some b tilde on the right hand side, right? So for no solution, if your all 0 rows have a non-zero on the right hand side, so any of the b r plus 1, b r plus 2, bm tildes are non-zero, then you will have no solution. So 0 and a non-zero, you will have a no solution. So if all zeros and this side also everything is 0, then you will have a chance of unique solution or infinitely many solutions. So all zeros and zeros, and if your number of non-zero rows, so number of non-zero rows are actually equal to the number of variables you have in your system of linear equations, then you will have a unique solution. Okay. So if your number of non-zero rows are lesser than your number of variables and these conditions are satisfying, your all zeros are having all zeros, then you will have infinitely many solutions. Okay, so we will solve problems, then we will get more clarity. Okay, all right. So let's try to comment on existence of the solution. Okay. So first and foremost thing we have to do is convert this particular system of linear equations into matrix vector form. So the matrix vector form is 1 minus 1 1 1 1 minus 1 minus 1 1 1 and a vertical line 2 3 4. Now remember our goal. You see the diagonal, and once you identify your diagonal, below the diagonal we should try to make them zeros. So that means, so we have to make these three entries zeros. All right, using row operations. So what I can do is I can change row 3 to row 3 plus row 1. So if I just simply do this, this becomes 0. Parallelly, I can also do change row 2 as row 2 minus row 1. All right. So what will we get if we do these two? So row 1, I am not changing anything, so it will stay as it is. Okay. Row 2 I am changing. Row 2 I am changing it as row 2 minus row 1. So row 2 minus row 1 is like 1 minus 1. This becomes 0. So 1 minus of minus 1. This becomes, this is 0. This is 2. Minus 1 minus 1. This is minus 2. So 0 minus 2. Sorry. 0 2 minus 2. And here also 3 minus 2 1. So if I write everything, I will get 0 2 minus 2 1. And row 3 also I am changing. Row 3 I am changing to row 3 plus row 1. So I just have to add. So I have to add 1 to minus 1, minus 1 to 1, 1 to 1, 2 to 4. If I add them, I will get 0 0 2 6.
6.
All right. So now I cannot. So this is the max I can do. I cannot make this 0. Actually, I can make this 0 by adding this. But instead what I am doing is, from this 0, it will get updated to 2. Like I no longer can keep these three zeros and bring in a new 0. That's what I wanted to say. Right? That means the number of non-zero rows I have is, how many non-zero rows?
3.
3.
3.
3 non-zero rows, right? And how many variables I have?
3.
X1,
3.
X2, X3. So if I just go back, did I have any all zero rows?
No.
No. So that means I no longer have to bother about no solution case,
Yes, sir.
right? So definitely this particular system has unique or infinitely many. And I tried to look at the non-zero rows. Like I tried to use that elimination process. And after doing the max eliminations possible, I have reached this point and none of the rows are zeros. Therefore, I have 3 non-zero rows and 3 variables. So that means my R is equals to N. So if R is equals to N, and since there aren't any all zero rows, I don't have to bother about this. If R is equals to N, then we will have a unique solution. Okay, so the answer for this is unique solution. Okay, so we'll solve one more problem. We will come back and get the solutions for this also, but we will just solve one more problem about this existence. Okay, so this is also mock question. So given three equations to us, which are system of linear equations, and there is an unknown variable k, and it is said that the given system has a unique solution. Okay, then k should not be equals to what value? Okay, so that's the question. All right. So I will give 2 minutes for you guys to solve it. Even though you have solved it in the mock, just try to solve it again here. Okay. So I'll just be back in 2 minutes. Okay. Any answers?
Sir, 15.
Okay, good. Actually, kind of small funny situation here. So I just came back and just saw the comment, and somebody has posted 15 at 4:26. I was kind of surprised that how they came to know the solution for this particular problem 1 hour ago. Then I realized that they have answered it for one of our earlier questions, which was actually wrong. Okay, so
Yes, sir. It's wrong.
okay. Okay, so let's try to solve this.
I think
Okay.
K is equal to 9, sir.
Okay, so we will see. So for this kind of problems, so a small shortcut for you guys, not shortcut, for things to be bit easier, what you try to do is you bring this unknown variable to the bottom most possible, right? Like, so when you write the matrix vector form, how will this look? 1, 3, 0, 3, k, 1, 2, 0, -1, 11, 49, 3, right? Your k is sitting at the center of your matrix, correct? So what you try is, try to bring that particular k at this position. Can I do that?
Yes, sir.
Basically,
Interchange.
you interchange this equation to the bottom. Okay, so that is nice. Even then, your k will come to just below. Then what you do is, so it's just variables, right? X, Y, Z. You consider X, Z, Y. Right? So you consider X variable as first column. Then you consider Z column coefficients as the second column. Then consider Y column coefficient. So Y coefficients as the third column. That also doesn't make any difference, right? So if you do that, your equation, your matrix representation will look like 1, 0, 3, 11. So this will be your first equation, because now we are doing X, Z, Y. Okay, so x, z, y. So this is x, this is z, this is y. Okay, and the second equation will be 2x minus z. So 2 minus 1, 0, and this will be 3. And the third equation will be 3, 1, k, and this will be 49. Right? Happy. Now, what we do is, it is said that it has a unique solution. So that's the key. So that means you should have, so you have 3 variables in your system of linear equations. So you should have 3 non-zero rows. Right? We have only 3 rows, and all 3 rows should be non-zero. Okay. So let's try to do that elimination process, the same elimination process, and see where we are reaching. Okay, so we do row 3, we will change it as row 3 minus 3 row 1. Correct. That's how I can make this 0. And row 2, I will do row 2 minus 2 row 1. Right? If I do these two operations, I will get the first row is unaltered like this. Now the second row is 2 minus 2 times of this. This will become 0. So this minus 1 minus 2 times of this. That is minus 1. So minus 1, 0. Again 0 minus 2 times of 3. So minus 6. Right? Now I have to do the same thing here also with these two. So 3 minus 2 times 11, which is 22. 3 minus 22 is minus 19. Similarly, row 3, now I have to do row 3 minus 3 times row 1. So first one will become 0. So 1 minus 3 times 0, which is 1 again. So k minus 3 times 3. Right? K minus 9. Right? And this is 49 minus 3 times 11, which is 49 minus 33, which will be 16.
16.
Correct? So far we have made these two zeros. Right? This 0. So far we have made this 0, this 0. We can also make more zeros. So our target is to make as many zeros as possible. That's it. So we can also make this as 0. How can I make this 0? I just have to add
By
these two
adding.
rows.
Yes,
Right?
sir.
So now row 3, I will change it to row 3 plus row 2. So if I do that, what will I get? So row 1 is as it is. Row 2 will also be as it is. Row 3 now will become 0, 0. So k minus 9 get added to minus 6. It will become k minus 15. Right? And these two get added to each other and this will become 3. Now observe this
Sir,
carefully.
sir, minus 3, right?
Oh, sorry, minus 3. So observe this carefully. So we have reached this point and it is known that the system has a unique solution. Okay. So you try to substitute values for k. Okay. So for any value you substitute this k minus 15. Okay. Will take some values, right? So if you take any real value, it will take some. But this k minus 15, if I classify, this can be greater than 0. This can be equals to 0. This can be less than 0. So k minus 15 less than 0 is again a possible case. Like you can have it. Because if you have k minus 15 less than 0, it will be like a non-zero element there. Once it is a non-zero element, you will have 3 non-zero rows. And 3 non-zero rows with 3 variables, you will have a unique solution. That is possible. So k minus 15 less than 0, you will have a unique solution. Similarly, k minus 15 greater than 0 also, if you see, if it is greater than 0, it will take some positive value other than 0. And once it is positive value, the row 3 will also be a non-zero row, right? So that means there is some non-zero element in your row. So once it is like that, you have 3 non-zero rows and 3 variables, you will have a unique solution. What happens when k is equals to 0?
No solution.
So when, sorry, k minus 15. So when this k minus 15 becomes 0, then you see you will have a complete 0 row. And when there is a complete 0 row, and on the right hand side, you have something non-zero. So have you seen this case? So some 0 row and right side is non-zero. So what is that? No solution case. So you have all zeros and one of your right side part is non-zero. If you see certain such cases, then there will not be any solution. So this particular system of linear equation either have a unique solution or no solution. But it is said that the system has unique solution. Then k must not be equal to 15. Right? If k is equals to 15, then you will not have a solution. Got it? Any
Yes,
doubt?
sir.
All right. So now, once after we reach this particular place, okay, so like the most number of zeros we got using these row operations, how do we get the solution? So the solution, to get the solution, we have to do the back substitution. So it is called back substitution. So we will go back to our previous example. Okay, so for solution, so we have reached this point. Once after reaching this point, what you have to do is, you see the last row. The last row contains 2 zeros and 1 non-zero. Okay. The previous row contains 1 0 and 2 non-zeros. And the first row contains 3 non-zeros. Okay. So from here, what you do is, from the last row, you get the value of z. How you get the value of z? Because if you write back as equations, so if you write this back as equations, you will get x1 minus x2 plus x3 is equals to 2 from the first row. From the second row, it is 2x2 minus 2x3 is equals to 1 from the second row. From the third row, you see that you will get 2x3 is equals to 6. Okay. So you see the last equation is just having a single variable and you can solve that. You solve that, you will get x3 is equals to 3. Right. So once you get x3 is equals to 3, what you have to do? You have to take back and substitute it in the above equation. Once you substitute it in the above equation, so x3 is equals to 3, you will substitute it here. You will, from here, you will get that x2 value, which is
7 by 2.
7 by 2. Right. So once you get x2 7 by 2, you take this value back to this equation. You take x3 value back to this equation. You substitute x2 and x1, x3 in this equation, and you will observe that x1 will be
5 by 2.
x1 5 by 2, correct. So 5 by 2. So concluding that it has a unique solution and finding that solution is the next step. So the solution is basically x1 is 5 by 2, x2 is 7 by 2, x3 is 3. So this is the only solution set possible. So solution set is 5 by 2 comma 7 by 2 comma 3. Okay. So this is the only solution possible. This is how we find. And if I go back and the simple example here. Okay, so this is now this should be very, very easy for us because it has only 2 rows and 2 columns. 18 1. So what do you have to do? We have to make, you have to identify the diagonal and make zeros below the diagonal. So there is only one entry, we have to make that as 0. So if I have to make that as 0, I will use row 2, I will change it to row 3 times row 2 minus 2 times row 1. Right? Or you can do row 2 minus 2 by 3 times row 1. Both are okay. Okay, so if I do this, what will I get? I am not changing row 1, it will just stay as it is. Now I am changing row 2, so I multiply 3 times row 2, which will become 6. So this becomes 6, and 2 times row 1 is 6. So 6 and 6 will get cancelled out and this becomes 0. Okay, now this becomes minus 3. I'm multiplying 3. So this becomes minus 3 and this becomes, so I have to multiply 2 minus 2. So this becomes minus 8. So minus 3 minus 8, that will become minus 11. Right? So minus 3 minus 8 will become minus 11. And this becomes 3 minus 2 times 18, which is 36. 3 minus 36 is minus 33. Right. So this is the best possible matrix that we can have. And here also you see we have 2 non-zero rows. Okay. And we have 2 variables. So 2 non-zero rows with 2 variables. Our R is being equals to n. Therefore, it will have a unique solution. Okay. So from here, again, substituting it back. So minus 11y is minus 33 from the second equation, from second row. So y will be 3. So once you get y, you just substitute in this equation. 3x plus 4y is equals to 18. If you substitute 12, 6, you will get x is equals to 2. Okay. And you can substitute them back and see your systems will, both the equations will get satisfied. Okay. So that is how we comment on the existence of the solution, as well as we can find the solution also. Okay. So let's solve one more example. Okay. So I think I have 2 more examples. I can finish this off quickly. So let's try to solve this
Excuse me,
together.
sir.
Yeah.
Sorry to interrupt.
Hmm.
Sir, will we discuss limits in today's class or not?
No, right? So limits, we have already done it in the previous revision session.
Okay, then
So
what
today
should
is
we
week
discuss
1 and
today?
2. Sorry.
Only week and 2, 1 and 2.
Correct. Week 3 and 4 is already done.
Okay, thank you.
Yeah. All right. So let's solve this particular example together quickly. Okay. So now we got enough experience, and 2 days ahead we have the exam. So we have to build the speed also equally. Okay. So the first and foremost thing is to convert this in the matrix vector form. Right. So if I write that in the matrix vector form, it will be 2 minus 1, 3, 4, 2 minus 1, 2 minus 5, 10, and 10, 12, 20. Okay. So now after reaching this point, you see your diagonal, and our goal is to make the bottom rows below the diagonal as zeros. So these 3 are there, so we have to make them zeros. And it's best to start with making these 2 zeros first and then make this 0. Okay. So in order to make this 0 and this 0, I will do row 3. I have to change row 3 as row 3 minus row 1. And row 2, I have to change row 2 minus 2 times row 1. Okay. So if I do these 2 operations, I will get 2 minus 1, 3, 10. This has 0, this has 0. That is why, so we want those 2 zeros. So that is why we are doing those operations. And so we will write down row 2 first. So for row 2, we have to do 2 times of this and then subtract. So 2 minus 2 times minus 1, which is 2 plus 2, which will become 4. right? So this will become 4. And this is like -1 minus 2 times 3, which is -1 minus 6, which is -7. And this is 12 minus 2 times 10, which is 12 minus 20 minus 8. And now the last row is row 3 minus row 1, simply. So 2 minus 2 is 0, minus 5, minus of -1 is -4, and
7.
10 minus 3 is 7, and 20 minus 10 is 10, right? Now we have to make this as 0. Okay, so if I make that as 0, I have to do row 3, I have to change it as row 3 plus row 2. Okay, so if I add these two, then this will become 0. So if I do that, 2 minus 1, 3, 10. Second row also I am not changing anything, 0, 4, minus 7, minus 8. Third row will become 0. I want this 0, that is why I have added. And while I am adding this, I got -7 plus 7, which will become 0. And 10 minus 8, which will become 2. Now you see, we have a 0 row, right? One row is completely 0 on the left hand side of that vertical line, but we have a non-zero entry on the right side. Okay, so if I write this back as equations, the last row is inconsistent equation basically. So it will just look like 0 on the left hand side is equals to 2 on the right hand side, no matter what the values of x, y, z are. Hence, we can conclude, what's the solution?
No solution.
Correct. So this will not have any solution, no solution. Okay. All right. So this is your key. Any row which has 0 and a non-zero on the right side, then it will be no solution. All right. So let's bring in some context into our system of linear equations. So consider a polynomial function of degree 3. Okay. So given by p of x is equals to ax cube plus bx square plus cx plus d. Okay. So this is a 3-degree polynomial. Okay. Now it is also given that the graph of p of x passes through the points -1, 5, 1, 11, and 2, 8. Okay. Now what we have to do is we have to form a system of linear equations, and on top of it, we need to find the matrix vector form that corresponds to the given data. Okay. So what should we do?
Put x value and equal to 5.
So basically, if this is x, if this is x, this will be p of x, right? Because these points should satisfy this equation. Okay. So this is -1. So 5 is basically p of -1. So p of -1 should be 5. P of 1 should be 11. P of 2 should be 8. So from p of -1 is equals to 5, p of -1 is a times -1 whole cube plus b times -1 whole square plus c times -1 plus d is equals to 5. And from here, p of 1 is a1 cube plus b1 square plus c1 plus d is equals to 11. And the final equation is p of 2. P of 2 is, you just have to substitute 2 here. You'll get a2 cube plus b2 square plus c2 plus d is equals to 8. Okay. So now what? I have to simplify. So first equation will just be -a plus b minus c plus d is equals to 5. The second equation will be a plus b plus c plus d is equals to 11. The last equation will be 8a plus 4b plus 2c plus d is equals to 8. So this is the system of linear equations, and this is how many variables?
4,
4 variables and equations?
3.
3 equations. Okay. So with this, it's good to write them down, because when you write the matrix vector form, you will not get confused. So if I write the matrix vector form of this, how will that look? Minus 1, 1, minus 1, 1, 1, 1, 1, 1, 8, 4, 2, 1. And this will be 5, 11, 8. Okay. So this will be the matrix vector form of the given information. So once you have the matrix vector form, the second part is find the complete solution to the given data. Okay. So we have this matrix vector form. Let me bring that. What the? Just a second. Hold on. What is this? Okay, so let me rewrite. So we have 1 minus 1, 1 minus 1. Sorry, minus 1, 1, minus 1, 1, 5, 1, 1, 1, 1, 11, 8, 4, 2, 1, 8. Right? So this is what we have. Now in order to find the solution again, so we'll try to make the bottom rows 0 and below the diagonal, we will try to make zeros. Okay, so that's our target. So we will do some row operations. So firstly, we have to make this 0. We can just multiply 8 to the first row and add it to the row 3. So now row 3, I will change it as row 3 plus 8 times row 1. Okay, and similarly, I can also make this 0. For that, I just have to simply row 2, I have to add row 2 with row 1. Okay, so if I do that, I will get first row will be minus 1 plus 1, minus 1 plus 1 and 5. The second row will be just the addition of first and second rows. So this will be 0, 2, 0, 2, 16. The last one will be, I have to multiply 8 to the row 1 and add it to row 3. So if I do that, I will get 0. And then this will be 12, because 4 plus 8 times 1, 12. And my 2 plus minus 8. So 2 minus 8, which is minus 6. And this will be 8 plus 1, which is 9. And then we have 13. Okay. So after this, I can make this also 0. So we can make this also 0, keeping these two zeros, right? Because I can just multiply 6 to this equation, just 6 to this row, and subtract it to the row 3. So I can do one more row operation, which is row 3. I can change it as row 3 minus 6 times row 2. Right? 6 times row 2. If I do that, I'll get minus 1 plus 1 minus 1 plus 1, 5. And 0, 2, 0, 2, 16. And this will be 0. And this will also be 0. And this will be minus 6. And this will be 9 minus
Minus
6
3.
times 2, minus 3. And 13 minus 6 times
96.
16. 96. 13 minus 96 is minus 83. Correct? Are we correct? Why am I getting ugly numbers?
Sir,
Fine.
I did some other row operations and I'm getting it here minus 23. Wait, let
Did
me
I
see
make any mistake?
Yes, sir.
All right. Oh, okay. So here I
In
have
the
to
place of 13, in the place of 13, there will be 48, sir.
Correct. So here 8 plus 8 times 5, which is 40. 40 plus 8 should be 48. So this is 48. So now it will be 48 minus 96. Right? 16 times 6 is 96. So this will be minus 48. Right? Okay, looks correct. Now we cannot do any further simplifications or further entries as zeros. Now we are struck. Correct? Okay. So I might extend by five more minutes. All right. So please bear. So now what we got is this. We have reached this point. If we want to further simplify, we can actually divide 3. I can do it row 3 by 3. Okay. So you can also do that, but nevertheless, it doesn't make any difference. So now what? So the last row, using just the last row, we cannot get the solution. Right? So now what is, we will assume some constant value to a variable. Okay. And how the best way to assume is, you see this, you select the first non-zero entry in each row. So in row 1, this is non. In row 2, this is the entry. In row 3, this is a non-zero entry. Right? After you see the non-zero entries, you noted down the non-zero entries, then you see which columns have that non-zero entry. So column 1 has that non-zero entry. Column 2 has that non-zero entry. Column 3 also has a non-zero entry. But column 4 doesn't have any this selected non-zero entry. Right? So because we have only 3 rows, so max first non-zero entries I can pick is 3 in each row, right? 1 in each row, I will have 3. So these are called pivots. Okay, so they are just named as pivots. Pivots are basically the first entries, first non-zero entries in each row. Okay, so once you identify the pivots and you see where these pivots in the columns, okay, via columns, how many columns has pivot columns? So those are called pivot columns. So the first column, second column, third column are pivot columns because it has a pivot element. Whereas column 4 doesn't have any pivot column. Okay. And see, go back and see which variable is referring to or representing column 4. So if you go back, variable D corresponds to column 4. Okay. Now it's a good practice to assume a constant value to variable D. Okay. So instead of assuming A to be K or B to be K or C to be K, it's good to assume D to be some K. Okay. Or U. In lectures, I think professor has used U. So you fix U, where U is some real number. Okay. Now fix this. So you fix or assume D is taking some real number U. Once you are okay with the D taking value U. Now come back to the last row. Okay, so come back to this row. This row is basically when you write it in equations, you will see that minus 6C minus 3D is equals to minus 48. So that's row 3. So this is row 3 equation. As I fixed D is equals to U, just substitute that here. Minus 48. Now this will get cancelled. 3 2 times 16 times. And if you simplify this, we will get the value of C in terms of U. So this is like 2C plus U is equals to 16. So C is equals to 16 minus U by 2. Okay. So we got C now. Once you have C and D in terms of U, take the second row, above row. Okay. So the above row corresponds to, when I write it in the equations, it will be 2B plus 2D is equals to 16. Again, from here, you know what D is. You fix D is equals to U. So 2B plus 2U is equals to 16. B is basically 8 minus U. So you got B as 8 minus U. Okay. And once you have B, C, D, you go back to the first equation. Okay. And substitute A, B, C, D to get value of A in terms of U. So if I write the first row in terms of equation, I will have minus A plus B minus C plus D is equals to 5. Okay. Yeah, Sujal, I will just come to you. So from here, if I just substitute all the other values, minus 16 minus U by 2 plus U is equals to 5. So from here, A is basically 8 minus U minus 16 minus U by 2 plus U minus 5. So if I simplify this, I will get 8 minus U minus 8 plus U by 2 plus U minus 5. So this and this will get cancelled, this and this will get cancelled out. So U minus 10 by 2. Okay. So finally, we will get the variable values in terms of U. So D is U, C is 16 minus U by 2, B is 8 minus U by 8 minus U, and A is U minus 10 by 2. Now, how do I write the solution? Okay. And this U is any real number. Okay. It's not 1 or 2. It's not fixed. You can take any real value. So now how I represent this solution is in terms of column vector. I will put A, B, C, D, all the variables in one column, and then just write what A is, what B is, what C is, and what D is in terms of U. So A is U minus 10 by 2. B is 8 minus U. C is 16 minus U by 2. And D is U. Now what you can do is, if you know the addition of vectors and all, or just it's not that difficult, you can just separate the U terms and the constant terms. So this I will write it as U by 2 minus 5, 8 minus U, 8 minus U by 2, and this is U. So now what I do is I will write U terms separately and constant terms separately. If I write U terms in the first entry, I will have U by 2, second entry minus U, third entry it is minus U by 2, and the last one is U, plus minus 5 constants separately, 8, 8, and I don't have any constant in the last entry, so it will be 0. Now you can just pull out U from the first vector, if you just pull out u, you will see that half minus 1 minus half 1 u plus minus 5880, and u can be any real number. So if you vary u, your solution will change. Okay, so this tells us that as u takes infinitely number of values, the solution to this particular system has infinitely many solutions. Yeah, Sujal, sorry.
Yes, sir. Sir, I have a doubt in mock test question number 12.
Okay, so I will just discuss. So any doubt in this particular question? So if not, then see, if you don't have any doubt, if you are able to solve these problems which I have shown you today, then even in the exam or in qualifier, you will be able to do it.
One doubt. Sir,
Hmm.
I was solved this example, find k, and I
Hmm.
stopped the k minus 9.
Okay.
I was stopped there.
So you stopped here.
Yes, yes,
So what if k is 9? There is a non-zero entry here, right?
yes.
So there can exist a solution, right?
Okay,
So why we fixed k cannot be 15. If k is 15, then you'll have all 0 rows, all 0 row. And there is a non-zero term here, which is inconsistent. So that is why we said k should not be 15. So if at all you reach that case here itself, like if you have 0, 0 and k minus 9, then k should not be equals to 9. Okay.
okay, okay.
All right. So this is for all the people who are in the session. Any doubts that we have discussed today? If you have followed me throughout this session, then I don't know. Suddenly
Hello,
the
sir.
system is getting hanged. Okay. So if you,
So if all the constant terms of the equations are 0 and the last row has a non-zero term in it, then what will we do? If
which one?
all
Which
the
one?
if all the constant in any one, if all the constant are 0 and the last row has a non-zero term in it.
Then also it is inconsistent, right? So I understood your
No.
point. So if you have 0 this side, am I in the call?
Yes, sir.
Hello? Okay. So your point is, instead of zeros on left side and non-zero on the right side, if I have 0 on the right side and some non-zeros on the left side, then what happens? Is that what your question?
Yes, sir.
So even then it is inconsistent, right? If you have non-zeros here and you have a 0 here, then if you write back to the equation form, then you will see that non-zero being equals to 0. Okay. Then, okay, sorry. My bad.
If the last term is like d and d is equals to 0.
D is equals to 0 will be the solution. Correct. Sorry, my bad. See, after 2 hours of continuous shouting, my brain cells are dead actually. All right. So the no solution case is only when you have non-zero on the left side and non-zero on the right side, only then no solution. If you have 0 here and if you have non-zeros here, then it forms an equation basically. That is all right. So you'll have something like 2x plus 3y is equals to 0, which is okay to have. So there can be values for x and y which actually satisfies that equation.
But sir, if all the terms are 0, like all the terms on the right side of the like column 5 has all the terms in it 0, and then the R3 has a single non-zero term, then what should we do?
Then that is what. So using the last row, you will decide that D will be 0. Okay. Right?
But sir,
Because these
if
are
D
all
will be
zeros.
0, then the above terms will also become 0, no?
So above terms will also become 0. Trivially, it says that the solution is unique solution and the solution is a trivial solution, which is 0, 0, 0, 0. All zeros. Okay.
sir.
If at all there is but there are many possible cases, man, in that also. So you can have matrix like this also. So it will be like 1, 1, 1, 0, 1, 2, 1, 0, minus 1, 1, 0, 0. Then you can have 0, 0, 1, and there can be all zeros. Okay, so sometimes you can reach this position also. So at this position, from the last equation, you can get that D is 0. But if you see the above equations, you can have non-zero solutions also possible. Okay.
Okay, sir.
Yeah. So
Sir,
yeah,
my
but
doubt
there will
is,
be solution. You have doubt in?
mock test question number 12.
Okay. Okay. I will take that. But before that, let me reconfirm from the students in the session. So I hope most of you got what we have discussed today and solve problems related to our discussion. Okay. And if you are aiming for 60 or 70, then you will definitely get if you just follow mock and revision sessions. But if your aim is to get 100 out of 100, then your concept should be clear and you should be thoroughly prepared. Okay, so let me open mock. So first problem I think I have discussed. We have discussed. Second one also we have discussed. Right. So third one also we have discussed. So 4, 5. So fourth and fifth are week 3 concepts, but I can just throw some light on this. Like question 4, anybody has any doubt?
No, sir.
Like just write down the terms and see. Okay, week 3, as I said, it is all about observing patterns in your sequences. Okay, so once if you are good at it, then week 3 questions will be slightly easier for us. Any doubt here?
Yes, sir. Can you solve the limit of Fn?
Just a second. Okay. So it is given that f of x is a polynomial, right? P of x is a 5-degree polynomial, and q of x is a 5-degree polynomial, and f of x is a rational function, right? And you have defined a sequence fn, which is f of n. Okay, so it is like f of 1, f of 2, f of 3, and so on. Okay, so that's the fn sequence. Okay, so the first term is f of 1. So the sequence of fn looks like this. F of 1, f of 2, f of 3, so on. Okay. So this is how the sequence fn looks. And now what is the question is about? It is about the limit of this function, right? Limit of this function, and it is also talking about limit of the sequence. Okay. So let's see what happens to the limit of the function first. So as f of x is 10x power 5 plus 4x power and so p naught divided by q of, so this should be q of x. This is 5x power 5 plus q4 x power 4 and so on q naught. Okay, so now if I have to talk about the limit x tends to infinite, what happens to f of x? Then again, if you substitute infinite, you will see that it will be in infinity by infinity form. Then the best way to do this is you just pull out x power 5 common from numerator and denominator. Then we will observe that limit x tends to infinite. If I pull out x power 5 from the numerator and denominator and cancel that out, you will see that you will be remained with 10 plus p4 by x. You will have by x square, p2 by x cube, p power 4 plus p naught by 5 whole divided by 5 plus again q4 by x by q2 by x cube 4 plus by x power 5. Now if I take x tends to infinite, all these terms will go to 0. Right? Even these terms, once all of them are zeros, this will just be 2. Okay, so limit x tends to infinite f of x is 2. Similarly, what happens to limit n tends to infinite fn? So what is fn? So what will be the infinite term? Like, so f of 1, f of 2, f of 3, f of 4 and so on. Here this will be f of n, nth term will be f of n. So this is simply limit n tends to infinite f of n, right? As x tends to infinite, the limit is going to 2. Even if I just sample at integer places, as n tends to infinite, this should go to 2. Right? So x is going to infinite, and even if I just consider the integer points, for all x it is going to, so as x is x any real number, if it is tending to infinite, it is going to 2. If I just simply look at the integer places, even the integer values of the function should also go and approach to 2. Right? Or you can again do this in this way also. You can just simply replace this with 10 n power 5 plus p n power 4, 5 n power 4 n power 4 with n, and then this tend n to infinite. Even from here also you will see that it is 2. Okay.
So can you please take question number 4?
Question number 4, you just write some terms. That's it. So you write a1, you write a2, you write a3, and you will see some pattern. So if you write a1, this minus 1 power n is just oscillation, right? So once it will be minus 1, another time it will be plus 1. So it will be minus 1 here, it will be plus 1 here, it will be minus 1 here, it will be plus 1 here, and so on. And here a1 is 1 minus 1, and this is 1 minus half, will be 1 minus 1 by, and this will be by 4. So as n increases, you will observe that your a1 is 0, but your a2 is half, your a3 is minus 2 by 3, your a4 is minus 3 by 4, sorry, plus 3 by 4. So like this. So as you progress, you will see that you will jump. So on real line, you can see it just simply on the real line. So if I consider a real line, your first term is at 0, but your next term is jumping to half. From half, you are jumping to minus 2 by 3. From minus 2 by 3, you jump to 3 by 4. And again, you come back. Again, like this, like this. As you go to infinite, you will slowly oscillate between minus 1 and plus 1. Okay. Yes.
But sir, how can we determine it's only jumping as we go to infinite, it will only go to -1, not beyond that?
Because you see this is n minus 1 by n, right? So n minus 1 numerator will always be lesser than the denominator, right? If you write more terms, you will see, even if you write a 100, what is a 100? It is just minus 1 whole power 100. So 1 minus something will always be less than 1, right? So in that way. Okay. Or you just consider this sequence as even sequence and odd sequence. See them as separately. Instead of this oscillation, you see 0, minus 2 by 3, minus 4 by 5, minus 6 by 7. So you see that as a different sequence. You see this as another even sequence as a different sequence, and you will see that one will go to minus 1 and another one will go to plus 1. Therefore, this will not be an increasing sequence. An upper bound
Sir,
for this sequence is half is also false. Yes.
in this question, I thought this sequence jumping like as up and down. Then I thought upward. Upper bound is 1
Correct. Upper bound is
and
1. Lower bound will be
lower
minus
bound
1.
is -1. But
Correct.
I mistake this. I thought up and down, and you will teach the between 1 and -1 and 1 in left to right.
Okay, so the graph is quite not nice. So you can actually look at the stem plot only. So if you see the stem plot, you start from n is equals to 1. N is equals to 1, it will be 0. Right? N is equals to 2, it's half. N is equals to 3, it's minus 2 by 3. The length will increase. N is equals to 4, it's 3 by 4. Further increase. Much more increase. Further increase. So it will oscillate up and down. Right? One time it will be positive, negative, positive, negative, positive, negative. Also the heights of the stems will slowly increase. Okay. So there
Yes.
you can see 1 and minus 1 will bound. But as n tends to infinite, it will not reach to 1. It will not reach to minus 1. It will oscillate between minus 1 and 1. Therefore, limit will not exist. Okay.
Yes,
So
sir.
C is wrong. Upper bound half is false because there are certain terms which are greater than half value.
Yes, sir.
3 by 4, for example. So this will also be wrong. A lower bound for the sequence an is minus 1, which is true because none of your sequence term will go below minus 1. Therefore, this will be correct.
Sir, if we consider epsilon naught is like as upper 1 by 2, and before the 1 by 2 is the my whole part is the epsilon naught, then limit is the 1 by 2. If
Sorry, what is epsilon naught?
Epsilon naught like as in definition of limit epsilon naught.
Don't get into those things. Not needed. Okay, so
Okay.
see, that is what I said. So as of now, you should find techniques to solve a particular problem. So the technique is very simple here. So with minimal effort, you can solve this particular problem. So if you bring in unnecessary stuff into this, then the problem becomes complicated. So just based on the 4 options, you just have to answer this. Okay.
Sir, can we say as n goes to higher and higher value, 1 by n will go to 0, and then
right. So that's the thing.
then minus 1 will be left, and if the higher number is odd, then it will be minus 1,
Plus
and
1.
if it is even, it will be 1.
Plus 1. Correct.
So
So it
it
will
just
oscillate, right? Even
oscillate.
odd, plus 1, minus 1, plus 1, minus 1. So limit does not exist. So that's it. That's the only key thing. Okay. So that is 4, 5. And this question we have discussed. Question 2 I skipped because it is just the graded assignment. So I solved similar problem earlier. So for this particular solution, you can just, this is direct graded assignment question. So you can go back and see the graded assignment question. And question 3, question 4. So which question did you ask? So I have like this. So is this the question you are asking?
Find the limit of sequence Bn.
Oh, Bn. So you got An's limit?
Yes, minus 14.
Minus 14 is 4An's limit.
Okay.
Sir,
So
in
An's
this
limit
question,
will be
so in this question, how will we solve for n is odd?
so that is what that is all the question trickiness lies. So for n is odd, you should understand what happens to this n by 2. What happens? So this is floor greatest integer, right? So when n is even, so when let's say n is 2k, what happens to floor of 2k by 2?
It will get a k.
It will simply be k. Whereas n is, let's say, odd, 2k plus 1. Now what happens to 2k plus 1 by 2?
K plus
K
1 by
plus
2.
1.
This is just integer. So this should be an integer.
K plus 1, sir.
So this is k plus half. Right?
Yes,
So
sir.
2k plus 1 by 2 is k plus half. So what is the greatest integer that is less than or equals to k plus half?
K.
K.
K. Right. So what is k in terms of n now? So n is 2k plus 1. What is k then?
N by 2.
So this n is 2k plus 1. So from here, what is k in terms of n? So it's like you bring 1 to the left side divided by 2. K will be n minus 1 by 2.
Okay, sir. Understood
Right?
now.
Now this floor n by 2 is basically n minus 1 by 2 if n is odd. Right? It will be n by 2 only. Right? Here k is n by 2 because n is even. It will be n by 2 only if n is even. Okay, so that's that you have to figure that out. Once you figure that out, here n is odd case, right? So you can simply replace this with n minus 1 by 2 and simplify to get a rational term. Okay. So from there, you can actually get the limit of even term sequence, the limit of odd term sequence. And if we say the limit exists, then both the values that you get should be equal. So from there, you can see that both the values will be equals to minus 3.5. So once it is minus 3.5, 4an will be minus 14. So it will just be 4 times the limit where an goes. Now coming to bn. So if you want limit n tends to infinity bn, then it's like limit n tends to infinity 2an square minus 7an. And we know limit n tends to infinity 2 times an square minus 7 times limit n tends to infinity an. Right. So from here I can simply write this as 2 times limit n tends to infinity an whole square minus 7 times limit n tends to infinity an. So we know what limit n tends to infinity an is, minus 3.5. If you just substitute 2 times minus 3.5 whole square minus 7 times minus 3.5. So if you simplify this, I assume you will get 49. Okay, so that is how you should solve. Question 4 is also slightly looks trickier, but the key thing lies is here. So if the side length of the first square is S1, this is the thing. And the second thing is how the second square or the next square is connected to the previous square. So this is like a recurrence kind of relation. So you have to find that recurrence relation between the side lengths, and do not get confused with area. Okay, so here SI, small SIs, or the recurrence relation is formed between the side lengths, and we are interested in areas. Okay, so you have to square them. So that's the thing there. And finally, this question, given a function, you should definitely be able to plot them on the curve. And once after plotting them, you should have to decide whether the limit exists at a particular point, or if limit doesn't exist, whether left hand limit, right hand limit, what are their values. If limit exists, whether it is continuous or not. Okay, so if it is
Sir,
not
can you explain
continuous,
this one?
this question.
Yeah, last one, 6.
Okay, so this is actually
For this,
connected to the above question.
yes, sir. So for this, I got the first graph.
First graph only. So that will be the correct answer. Okay, so once you have the correct answer with you, so do you think x power 1 by 5 plus 2 is bounded anywhere?
No,
As
sir.
x tends to infinity, what happens? What happens to this x power 1 by 5?
It will go infinity.
It will go infinity, right? So once it is going to infinity, it is not bounded at all. So f of x is bounded is the wrong option. Bounded means there should be a maximum value to the function and a minimum value to the function. So here there is no maximum value. Maximum value is infinite, right?
Yes, sir.
Yes, sir.
So the next option says f of x is right continuous at x is equals to 0. So you see at x is equals to 0. So at x is equals to 0, the value is 1. In order to be right continuous, the right limit should be equals to the function value, right? So when you find the right limit, which is limit x tends to 0 plus f of x, should be equals to f of 0. So f of 0 is 1. But from the right side of 0, the function behaves like x power 1 by 5 plus 2, right? So
Yes,
when it comes closer to 0, it will take value 2, right? So 2 not equals to 1, right?
yes, sir.
So even from the graph also you can see. So if I come from right side, I will approach to this value, whereas actually at that particular point the function value is 1. So the right limit is not equals to the function value, therefore it is not right continuous, therefore this option is also wrong. Okay,
Sir, we
as
can say
extends,
left continuous, right?
it will be left continuous, but it is not there here, right? It will be left continuous.
Okay, sir.
Okay, and as x tends to minus infinite, what happens to f of x? As x tends to minus infinite, you will see 5 power x, it behaves like 5 power x. So limit x tends to minus infinite, what happens to 5 power x? What happens? It will be
It
5
will go
power
to
minus
0.
infinite, 0, correct? So kind of 5 power minus infinite, which will be 0. So therefore, this will be a correct option. And limit x tends to 0 plus f of x. So it is like right limit, right hand limit. So just now we saw right hand limit is actually 2. Right? So this limit x tends to 0 plus f of x is 2. But limit x tends to 0 minus f of x is 1. And this is equals to f of 0. So this will be left continuous. And this option is also wrong.
Okay, sir. Thank you, sir.
Okay,
Sir,
sir.
I
Thank you.
didn't saw the
Yeah.
minus
Graph
infinity.
1 and 3 are kind of similar. So how can we differentiate which graph is correct?
That's a good question. So now you see, this is like a quadratic, right? Polynomial, right? So you should have a basic understanding of how x power a behaves when a less than 1 and when a greater than 1. So this I think professor has discussed in the lecture also. So polynomials have this kind of behavior. So it's like an increasing, right? So straight away increasing. Whereas square root x, cube root x, fifth root x, everything will have this kind of behaviors. So there will be increase, but there will be high increase at smaller values of x, and as x increases, there will be lesser increase. Whereas, so this x power a, when a is greater than 1, you will see these kind of graphs. When x power a less than 1, you will see these kind of graphs. Okay. So this is a graph where it represents something like x square or x cube or x power 4 or something like that. Not x power 1 by 5. Okay. So this graph actually represents that x power 1 by 5. All right. So I think, okay, so we have discussed mock questions also then. We have revised week 1 and 2. We have discussed mock questions. I will upload this PDF. I will ask team to upload this on portal. Most probably by tonight, or if delayed, you will get it by tomorrow morning. Okay. So all the very best for your qualifier exam. So if you want to celebrate the Diwali happily with 70% of the marks, as I said, you can just simply follow our revision sessions and mock. But if you want to celebrate a great Diwali, then you have to go through all the concepts. Okay. So all the very best for your exams and advance happy Diwali to all of you.
Sir, about the graded assignment 3, question number 1.
Yes, I will look into it. Yeah.
Okay. Okay, thank you.
Thanks.